Hello, Applied Physics students. Here's your concept development practice page 13.4 teaching video about tides, ocean tides. So number 1 says, consider two equal mass blobs of water, A and B, initially at rest in the moon's gravitational field. The vector shows the gravitational force of the moon on A. So this is the force of gravity on this blob from the moon. Draw a force vector on B due to the moon's gravity. Well, right, we've looked at how gravitational force is affected by distance. We know these are equal mass, but the distance of this one is greater, which means it should be less. And it's quite a bit less because remember that distance is squared. So we're going to make this quite a bit smaller. Okay, vector. So there's my force vector on B. Is the force on B more or less than the force on A? Well, it would be less. And why is that? Because it is farther away from the moon. Therefore, the gravitational force is less. Okay, they're inversely proportional. As my distance increases, my gravitational force decreases. The blobs accelerate toward the moon. Which has the greater acceleration? Well, more net force means more acceleration, so A is going to have greater acceleration, okay, because the force is larger. Therefore, more acceleration. Because of the different accelerations with time, right, so this one is moving closer to the moon faster than this one is. So A is going to get farther ahead of B, and the distance between them is going to get more, right? They're going to increase their distance. If A and B were connected by a rubber band, with the time the rubber band would, so if this is the rubber band, right, we imagine a rubber band here, and we know that with time, this is going to get closer to the moon faster, and the distance between these is going to increase, that rubber band would have to stretch. This stretching is due to the blank in the moon's gravitational pull. There's a difference, right? The difference, the moon pulls on this blob with more force than this blob because this blob is closer to the moon than blob B is. The two blobs will eventually crash into the moon. To orbit around the moon instead of crashing into it, the blobs should move tangentially. That means like in a straight line. Right? Basically, that means they're going to orbit the moon. Then their acceleration will consist of changes in direction. So they wouldn't be changing speed, they'd be moving around, okay, the moon with a constant speed, but they're accelerating because the direction is constantly changing because they're moving in a circular path. So number 2 says, now consider the same two blobs located on opposite sides of Earth. So we're looking at the same blobs as we did up here. Okay, we just said that it's on Earth. Because of differences in the moon's pull on the blobs, they tend to, well, we already said what's going to happen to them. They're going to spread away from each other for the same reasons that we said up here. Does the spreading produce ocean tides? Yeah, that's what's going to produce these ocean tides. If Earth and moon were closer, gravitational force between them would be, remember, if I move closer, my gravitational force is going to be more. And the difference in gravitational forces on the near and far parts of the ocean would be more. Because Earth's orbit about the Sun is slightly elliptical, Earth and Sun are closer in December than in June. Taking the Sun's tidal force into account, on a world average, ocean tides are greater in December because the Earth and the Moon are closer together. So again, this causes tides because this pull here on the water on Earth is greater than the pull here. So this kind of pulls this water differently than it pulls the water here, and it causes tides. So tides are because of the gravitational forces between the Moon and Earth, specifically the water on the surface of the Earth. Because the water can move and get pulled, okay, more than the Earth's surface can, we create tides. Have a great day. I'll talk to you tomorrow.